Gulamanaka everyone. We were supposed to design a microlearning environment video, which is part of the requirement for ED403 course. My name is Dr. Jairaj, and I'm an assistant lecturer in mathematics with the School of Information Technology, Engineering, Mathematics, and Physics. The course that I'll be looking into is Mathematics for Science, which is MA102. And the topic of interest is limits. These two figures basically gives just some hints on what limits are about. It is designed or given such just to create or give attention to the students that we are going to be looking into the concept of limits. The outline for the course is as follows. We'll have the course and its description, the course learning outcomes, the concept map for the course, of course, the concept to be taught for limits, right? On the topic of limits, of course, which will be the topic learning outcomes, brief summary of the lesson, what are you going to look into, the resources that we'll be using, what will be the teacher's resources, that means the resources that I'll be using, the student resources, the activities for the students, assessment tasks, and the formative assessment. So the course, Mathematics for Science, MA102. The mode of delivery for this course is online for this semester because, of course, of the COVID-19 scenario that we are faced with. The course description. This is a service course designed to provide a learning knowledge of commonly used mathematical methods. It is a terminating course and it is not available to students intending to pursue mathematics as a major or a minor, and it's not suitable for students of physics or engineering. It has basic mathematics skills, that is why it is such. The course covers those areas of statistics and calculus, which are likely to be demanded in the disciplines of biology, chemistry, earth science, environmental and marine science, and some other areas of technology that are there. The course learning outcomes. Upon the completion of the course, students in the course should be able to go through or have these 4 learning outcomes. They should be able to develop the problem solving skills, apply different techniques for solving systems of linear equations, apply principles of differentiation and integration to solve simple life problems. And this is the course learning outcome that is of interest for us. And of course, the last part of the course learning outcome is to apply basic statistical techniques to organize, describe, analyze data to solve real life problems. The concept map for calculus is such. Under calculus, there are 5 main topics. We have got functions, we have got limits, we've got continuity, differentiability, and integration. And each of these topics has got its own subtopics in there. So for these micro LED, our focus is on limits. Now, we should note that the concept of calculus is built up on 5 things. The 5 things are, of course, functions, then limits, then continuity, then differentiability, and finally integration. So those are the 5 orders that we are going to look at. So for limits, right, it is divided into these sub 3 topics. We can use L'Hopital's rule to find limits. We can use the sandwich theorem, and we can use the discontinuous functions. And in that, we've got jumps, infinite, and removable discontinuities that we shall be looking to. So the topic learning outcomes is as follows. At the end of this topic, the students should be able to evaluate limits of polynomials and rational functions at infinity and find the derivative of functions using the definition of the derivative. So this is what is required. Brief summary of the lesson. A limit tells us the value that a function approaches at that function's inputs gets closer and closer to some number. So in fact, what limit, the basic idea of limit is we are interested on what is the behavior of the function around or about a point. It is not what happens on the basic point. Okay. And the idea of limits, it is the basis of calculus, and its applications are many. The practical applications of that, we can have rates of change, we can have compounded interest, we can have defining irrational numbers like pi or exponent, right? Like the number 3.14, that is pi, right? And we say happy pi day to people when we come to that place. Pretty much any result from calculus, derivatives and integrals, all depends on limits. And limits at infinity are useful for describing the a and b of a function. What we want to expect to know is what happens at the end of a particular function. So the limits will be very useful in that. Next is teacher's resources. The resources which I shall be using to make up my notes will be made from or coming from textbooks. Right. I'll be summarizing these notes, and the lecture will be presented via BBB or Zoom. And of course, after the topic, there will be some activities which are designed for the students to carry out that will test their knowledge of understanding of the matter. And following that, we of course got the students' resources. In the student resources, we'll have the lecture notes, the summary of the lecture notes that are there. The supplementary reading. If students are not able to grasp concepts using the lecture notes that are there, then supplementing readings are available for students to learn more from the topic. Of course, there are tutorials after every activity. So the students will have to go through the tutorials for this particular subtopic that there. And for that subtopic, there are lab activities that are designed for it as well. These lab activities is done via some computational technology. For instance, in MA102, we use Mathematica for that. And there are videos which students can also look into to grasp the particular topic more. The teacher activity, lesson opening. This is where the students will be greeted. The students will be told about the lesson outcomes, and also have a fair idea about the students' prior knowledge of the topic matter. Then introduction of the topic, the lesson objectives are discussed, and it is then also related to the topics that was done previously. A discussion on the content is then carried out, and relevant questions are asked to the students to see their knowledge on the information. And once this is done, in the lectures, an activity would be given to the students to try it out to see what is their understanding on the particular topic, which will be, of course, on limits. The students are then asked to present their answers. We normally ask them what answers have you got, and see if they've actually come to the right place. And then, of course, the lesson is recapped. The importance of the limits is being told, and where would the concept of limits be used next is then explained to the students. So this is the teacher activity. For students, right, they are to come to class, right, and they are to answer the questions and listening to the lecture that is going to happen. The topic is introduced to the class. Students are expected to pay attention to the lesson objectives and respond to questions if there are questions that are being asked. And while problems are being solved in class, examples are being done, students are expected to pay attention in class and jot down the important points or concepts that are being taught. The activity, they will be given some homework exercises, some tutorial problems, some lab exercises for them to carry it out. A presentation of the student work. Normally in tutorials, we ask the students to come up on the board and solve a question on to see their understanding on the topic. And finally, conclusion, the teacher takes note if the students have any difficulty on the topic, and then that could be revisited. Assessment tasks. We have got the lesson opening, we've got basic understanding of the topic happens. Topics are being related to what was taught previously and what will be taught next, and how the topic is later to the concept on calculus. Introduction of the topic, brainstorming activity takes place, applying learning objectives within the topic. And where are those in the learning objectives that we are doing for the particular lesson, where will they be applied? That is a very important concept to make sure that students have or understand that mathematics is very useful in every aspect of life. Then it follows by a discussion where students to follow and make important notes as discussion takes place. This is a very important task for the students to do. And of course, after which there'll be activity based on limits. We can have weekly quizzes for that matter. Presentation of the student work. Students will be expected to present their answers to the class. And of course, while presenting, the lecturer will be able to see if the critical thinking is actually taking place in the class. And for that, there is a formative assessment. The formative assessment is in terms of a quiz. We will design a quiz and give this to the students. There is a question bank for the quiz that is there. This will allow the students to go over the quiz, and also ensuring that they do not copy answers or copy from their friends. That is why there is a huge question bank that is there. Now, what is the reason for the online quiz? Is to provide feedback and provide self-evaluation to the students. The online quiz allows students to improve and understand on the concept of limits. This promotes learning and students can easily gain marks with less coverage being tested. There will be a total of 10 questions with the time allocation of 1 hour. The mark is converted to 1%, which contributes to the students' coursework. This is a sample of the MA102 quiz that we could have. We have true and false questions, and we have got multiple choice questions. We also design questions such that the students have to do the question just like what is an example in question 2, and they need to choose an answer for that is there. And so this is a sample of the quiz that we can actually have. And so this basically sums up the micro LED for the topic on limits for the course MA102 Mathematics for Science. I'll be waiting for further discussions and your recommendations on this topic. Thank you so much, and Vinaka Bakalev.